push versus pull system, Kanban, and make to order. So what is the difference between push system and a pull system? In a push system, for example, in material requirements planning or enterprise resource planning, flow units are allowed to enter the process, right, or be processed or produced, independent of the current amount of work in progress. In the worst case, if the first resources in the process have low utilization, they are likely to flood downstream resources with inventory. In a pull system, resource furthest downstream, i.e., the one that is closest to the market, to the customer demand, is paced by market demand, and it relays demand information to stations upstream through the information that it requests some parts from it, and that ensures that they are also paced by the demand. So a pull system systematically limits work releases and through that limits the work in progress inventory. The advantages of pull are, first of all, observability. Because we have small work in progress inventory that is stored on the location, like at the end of the production station, it is easy to observe. Efficiency, of course, we will have less inventory, and that means it's a smaller investment and for the same throughput. And the third advantage is robustness. Robustness here means that if you make an error in the push system and set too high or too low release rate, you will have a very high cost either of overproduction or shortage. In contrast, if you set wrong work in progress level, right? If you set incorrect, maybe too low or too high limits on the inventory levels, then the costs of that will not be as much as in the push system, setting the wrong release rate. There are two forms of pull system that are advocated by the lean production systems. The first is called Kanban, sometimes also called fill-up or supermarket pull, and the second is called make to order. The Kanban system was originally organized with boxes and Kanban cards, but nowadays can be supported by some information systems that replace, for example, the Kanban cards. But the logic is still the same. The idea is that as a manager, you can define how many Kanban cards you allow the system to have. And by defining the number of Kanban cards, for example, 3 or 4, you might say how many boxes of parts are allowed to be there. Let's say each box contains, as in this example, 9 parts. So you see here, what happens is that if there are only 4 Kanban cards, and in total you might have at most 4 boxes of 9 parts, so a total of 36 parts of this type. And only when the downstream resource uses a box of 9 parts, it then sends a card to the upstream resource, and that authorizes the production of 9 units with filling up another box that is booked as the work in progress inventory. So you can see that this is a way to limit the amount of inventory of those parts. There can never be more than 4 boxes of 9 parts. And at the same time, it is a way of synchronizing production. So if this downstream resource doesn't use too many parts of a certain type, the upstream resource has to slow down production, and it will not overproduce because it can only produce when it is authorized by the Kanban card. So the second type of the pull process is called the make to order process. And basically in this case, all resources operate only after we receive an explicit order from a customer. So in this example, we might not have any inventory between different resources. All we might have is idle resources that are waiting for an order of the customer, and the moment that order is received, those resources can initiate production, and the parts can go through all the steps until the finished product is built just for the customer order. Typically, products in this process will be processed in a first in, first out fashion. And of course, each flow unit within the process is explicitly assigned to one specific customer order, which also means that it can be, for example, highly customized for a specific customer. So when do we use Kanban and when do we use make to order? Well, we use Kanban for products or parts when we process them in high volume and limited variety. So there is some variety, but not a lot, and there is a very high volume. When we require a short lead time, so customers cannot wait, so it makes economic sense to have some limited number of parts produced ahead of time and for which the costs and efforts related to storing components are relatively low. For example, those components do not become outdated or obsolete. On the other hand, we should use make-to-order pull process for products or parts when they are processed in a very low volume and very high variety. In that case, it would be very hard to store a large variety of products. It would mean a lot of inventory, even if each variant is stored in just a few units. Also, it is possible when customers are willing to wait for their order a longer time. And also, it is necessary sometimes when it is expensive or difficult to store the flow units. Notice that many organizations might use both of pull systems. For example, Dell computers are assembled in a make-to-order fashion. The assembly line of computers only assembles a computer that was ordered by a client and maybe even paid for with a client's credit card. On the other hand, components for those computers might be replenished using something that is similar to a Kanban system. So when the number of available components of a certain type is reduced to below a certain threshold, we might replenish a quantity from the supplier.